Hello, integrated math students. Today we're going to be going over the Unit 1 unit activity. So if you're already at that assignment, go ahead and open it up and we'll go ahead and get started. Hopefully up to this point, you've completed the rest of the tutorials and mastery tests up to the activity. And if you have, then you're ready for the activity. If you haven't, go ahead and do those first because the activity covers basically all that material. Okay, well, with that, let me go ahead and share my screen and we'll go ahead and get started. So if you open up the activity, you should see Integrated 3, Unit 1, Preparing for Integrated 3. So when you click on this will open up the activity. Now, you might notice that you won't be able to edit anything. And there's this button here that says Request Edit Access. Don't bother with that. What you want to do is you want to go over to File here, and then what you want to go is Make a Copy. So you make a copy and just press OK. And then when you have this copy, you can edit this. So once you have the copy, then you can edit it. You could put your name here and your teacher and so on. You don't necessarily have to fill that out because your teacher will know it's from you, but yeah. Now, when you go down to the first task, you'll see right here, part A, simplify each expression. Final answers should not contain parentheses or negative exponents or fractional exponents. Okay. Now, for me, this is very hard to see. It's extremely small text here. So what you can do is just go ahead and highlight that. And then over on the toolbar, you'll see there's like a font size. Just go ahead and press a couple pluses here, and that'll increase the font size just like that. Okay, now you can clearly see, oh, this is 12m to the 8th over 6m to the negative 3. Okay, now for the rest of these, I'm going to go ahead and increase all of their sizes to make them a little bit easier for me to read. And I would suggest doing this. It'll definitely help you make fewer mistakes, and it'll make it easier for your teacher to grade as well. Okay. All right. Okay. The rest of the assignment is of normal text size and we should be able to read that. Okay. Well, let's go ahead and get started with part A here. So I'm going to go ahead and take a snip of these problems here, and I'm going to work out this one here. So the first thing here is, well, I notice I have this m to the negative 3 in the denominator, right? So generally, if I see a negative power, I want to move where it's at. So since these are m to the power of negative 3 in the denominator, it's going to move up to the numerator and become a positive power. So on the top now, we have 12 m to the 8th, and I move those m to the thirds up to the top. And then I still have a 6 on the bottom. Now we can go ahead and combine these two m to the power of 8 and m to the power of 3. We can combine those by adding the powers. Remember, if they're multiplying here, if they have the same base, you just go ahead and add those powers. So we're going to have m to the 8 plus 3 is 11. And also we could do the 12 divided by 6. 12 divided by 6 is 2. So our answer will be 2m to the 11th. Let's go ahead and work on the next one. Here, when we have two things multiplied, generally we want to do this exponent first. Notice this cubed on this 2y. So that'll be 2y times 2y times 2y. But another way to think about it is that this cubed will go to the 2 and to the y. So I'm going to go ahead and rewrite this question. 4xy to the negative 2. And then I'm going to, basically this cubed is going to go to the 2. So 2 cubed, which is 2 times 2 times 2, well, that's 8. And then we'll have y to the third, because this cubed, this third, goes to the 2 and to the y. It goes to everything in the parentheses here. Okay? Now we can go ahead and combine these by multiplying here. All right. So when we're multiplying these, what first thing we want to think about is multiplying the coefficients. So the 4 and the 8 here, those are going to multiply. So that's going to be 32. And then the x. And then what about our y's? Well, like I showed over here, if we have the same base, we could just go ahead and add those powers. So -2 plus 3 is 1. So that's y to the 1. Of course, if it's the 1 power, you don't need to put it. If you do put it, that's fine, but you don't need to. Okay? And throughout this, I would suggest writing down these steps. You know, writing down these steps as you go on there. Okay? If you want, you could do it on a separate piece of paper and then transfer that over as well. Okay, next one, number 3 here. Notice that we have this 1/2 power outside this parentheses. That means everything in the parentheses is going to get this 1/2 power. All right, so let's go ahead and put that in. Well, this will be 4 to the 1/2. Now, what about when we do x to the 8th to the power of 1/2? Well, when you see a power to a power, what you do is multiply those powers. So here we're going to have 8 times 1/2. And just as a reminder, if I do 8 times 1/2, I could think of this as 8 over 1. And when we multiply fractions, you multiply top times top, bottom times the bottom. So that's 8 over 2, which is 4. Which I hope makes sense because 8 times 1/2 is the same as saying, what's half of 8? Well, 4. So when we have a power to a power, we multiply those powers. That's the main thing I want you to see there. So 8 times 1/2 will be now x to the power of 4. Then y to the power of, well, what's half of 2? Well, that's 1. Again, to the 1 power, I don't need to write that. This 1/2 also goes to everything in the denominator. So here we're going to have 16 to the power of 1/2. And then x to the power of, well, what's half of 4? Well, that's 2. And then y to the power of, what's half of 6? That's 3. Okay. Now, notice we still have this 4 to the power of 1/2. One thing we want to kind of note is that when we see a fractional power on something, that's, in the case of 1/2, that's the same as saying the square root of 4. And hopefully you remember that the square root of 4 is 2. The reason why is because the square root of something is saying what times itself gives you that. So in this case, the square root of 4 is asking what times itself gives you 4? Well, the answer is 2. Okay, so 4 to the power of 1/2 will be 2 in our case. So let's go ahead and I'm going to work out these to the power of 1/2 here. In other words, take the square root of 4 here. That's 2. And the square root of 16 is 4. I'm just going to go ahead and rewrite all the other stuff here. Okay. Now, this 2 over 4, I could reduce this by dividing both top and bottom by 2. So that would be 1 over 2 when I divide by 2. I'll just put a 2 in the... Hey, I didn't mean to do that. Stop that. Okay. If I write off the edge here, it'll just keep on writing. Okay. So reducing both top and bottom by 2 will give us 1 over 2, but I don't need to write the 1 on top. So I'll just put the 2 on the bottom. Now, what about the x's? Well, when we're dividing here, what you do is you subtract the powers. And so 4 minus 2 is 2. So we're going to have x squared. And the reason it's on top is because we have more of them on top. Okay? Imagine 4x's on top, 2 on the bottom. 2 of them would cancel, but you would be left with 2 more on top. Same with the y's. You go ahead and subtract these powers. Again, this is like to the power of 1. And you're going to be left with y squared. But this time, they'll be remaining on bottom because you have more on bottom. So I'd say this is our final answer here. Okay. Now, when we're writing in here, you know, you could put in your work equals yada, yada. And, but you might want to use, I wonder if there's like an equation tool. insert equation. Yeah. So you can insert an equation here and it'll turn out much nicer. It'll look mathier, basically. Okay. So like for our answer here, it was 2n to the 11th. So let's see, we'd write 2 and then m to the power of 11. Okay, just like that. You see how that comes out very nice, right? Using that equation editor. And the way I got to that equation editor, again, I'll show you again. You go to tools. No, it wasn't tools. It was insert. Insert, and then you go to equation, and then you could put in an equation just like that. Okay. Now, how did I do this exponent? Well, that's using the to the power button. So what I did is, if you notice on your keyboard, you'll see the number 6, and you'll see there's like a little, what we call a caret, right? If you look on your keyboard on your computer, you'll see like the number 6 button has like a little, this symbol above it. This is how you get to the exponent. So this button, you'll hold to get this caret, you'll do shift. So you'll hold shift button, and then when you press 6, it gives you the upper exponent. Okay. So that's how you write that. Okay. Okay. This one will have like a fraction in it, right? So you'll put insert equation and then equals, and you can put a fraction here. Let's see how it turns out. Okay, that's not my favorite. I wonder if you can do and let's see, maybe I could do a way to do a fraction here. It's not too big of a deal. You can write it with the slash, where you'd put the numerator on the left and the denominator on the right. That's fine. Okay, but I want you to show your work here. So show your steps as you go. So for these ones, I don't want just the answer. I want you to show like this, all the steps here. Okay, showing all the steps is how you get full credit for this. Okay, same thing here. Okay, I know that takes quite a bit more time, but that's what I'm looking for. Okay. With that being said, let's go ahead and solve these equations here for part B. The first thing I would do for number 4 is distribute this 3. So 3 times c and then 3 times 4. So that's 3c plus 12. And again, you can do this work on another sheet of paper and then transfer your work over to on this if you want. The right side of the equation, we'll just rewrite it for now. Now notice there's c's on both sides of the equation. Generally, we don't like that. We want all of our variables that we're solving for, we want it all on the same side of the equation. So in this case, we have c's on both sides. We don't want that. So what we're going to do is go ahead and subtract 5c, both sides of the equation. So that'll give us negative 2c on the left. There's still a 12. Then on the right, 14. Next, we would subtract 12 both sides. So that'll give you negative 2c equals 14 minus 12 is 2. Divide both sides by negative 2 to get c by itself. C equals negative 1. Okay. Now, when you're showing your work, I would you don't have to show everything, but I would show at least a few steps. So maybe show this, and then show this, and then show this, and then show this. Okay. Now, for the next one, notice this has an absolute value. When it has an absolute value, what this can basically do is split into 2 different equations. So it'll be 3 minus 2x equals 7. And then the second one would be 3 minus 2x equals negative 7. Okay, so now what you do is solve each of these equations separately. And so you will get 2 answers for this one. So I'll show you how to do this one, and you can do this one on your own. But I want to see both answers as in your answer. So what I would do here first is subtract 3 both sides. So this will give me negative 2x on the left equals, and then 7 minus 3 is 4. Divide both sides by negative 2. That gives me x equals negative 2. Okay, so that's one of the answers. I want you to go ahead and solve this one on your own. Now for number 6, the way we need to solve this, notice we have x squared plus x minus 20. So here I want to factor this trinomial over here on the left. Now hopefully you remember how to factor. I like to show with like this magic x or whatever. But basically you'd put the constant term on top, in our case negative 20, and then we'd put the b term or the linear coefficient on bottom. So in this case, notice it just has an x. So there's the coefficient here would be 1, right? Because there's like an invisible 1x. So what we're looking for are two numbers that multiply to give me negative 20, but add up to give me 1. So the answer here would be 5 and negative 4. Notice they multiply to give you negative 20, and they add up to give you positive 1. So how does that tell us how to rewrite this? Well, this tells us it needs to rewrite as x plus 5 times x minus 4. And it still says equals 0. So the right side doesn't change. Now what you do is you set each of these equal to 0. So x plus 5 equals 0. And then x minus 4 equals 0. And then you solve each of these. So for this left one, to solve for x, what I would do is subtract 5 both sides. Now give me x equals negative 5. So our first answer here is x equals negative 5. And again, show some of the work. Show maybe this step here, this here, and then this here. Okay. I'll let you do this equation on your own, but you should get a second answer. Okay. Again, this will have 2 answers, just like number 5 had 2 answers. Okay. Let's move on to the next step. So part C, solve and graph each inequality. Okay. So let's go ahead and I'll show you how to do these ones. Mostly solving an inequality is very similar to solving an equation, where whatever we do on one side, we do on the other, and we're trying to get x or whatever variable by itself. So this one, for example, what would I do first? Well, hopefully you'd see, oh, I could distribute here. Okay, so here, 4 times x, that's 4x, minus, and then 4 times 6 is 24. Now it's negative 24 because it was 4 times negative 6, so that makes it negative 24. And then greater than or equal to 20. So if we're trying to get x by itself, what step would we take next? Well, we would add 24 to both sides. Adding 24 to both sides gives us 4x is greater than or equal to, and then 20 plus 24 is 44. What would be the next step to help us get x by itself? Well, hopefully you'd see, oh, I can divide both sides by 4 to cancel that out. This will give us that x is greater than or equal to 11. And that'll be it. Now it also says graph each inequality. So the way you'd graph that, you don't have to, and what they're saying is graph on a number line. Now for me, when I'm graphing on a number line, I don't want to see a bunch of numbers. I don't want to see, oh, 0 all the way to negative 11 and 0 to 11, you know, all that. I don't need to see all that. What I would just put is, okay, here's 0. Show me where 0 is, and then show me where your number is. So in our case, 11 is over here. Okay. You don't need to put all the dashes in between there. That's not a big deal to me. Now, it says x is greater than or equal to. So would this be an open circle or a closed circle? Should I color this in or leave it like it is? Well, if it has the or equal to, we want to shade that in. Okay, so if it has greater than or equal to, so it has this equal part, then we want to shade that in. Now, in our case, x is greater than or equal to, so that'll be the numbers over here, right? These numbers over here are greater than 11. Okay, and when it says graph it, that's as much as I want. Okay, next one. Here we have a fraction. We got x minus 5 over 7 is less than or equal to -3. Now, generally, when I see a fraction, I want to get rid of it. So the first thing I want to do is get rid of this fraction. And the way you do that is just by multiplying by whatever's in the denominator. So in our case, that's 7. So we're going to multiply both sides of this equation by 7 to help us get this fraction gotten rid of. So that cancels that. And the reason why multiplying by 7 cancels is because this is like dividing by 7 here, right? So multiplying by 7 is the opposite. Okay. And whatever we do on one side, we have to do on the other. So multiply the right side also by 7. So here we'll have -21 over here on the right. And then on the left, we still have x minus 5. Okay. What would be my next step to help me get x by itself? Well, hopefully you'd see, oh, I can add 5 both sides. So that'll give us x is less than or equal to, and then -21 plus 5 is -16. How would I graph that? So again, let's look at our number line. Here, my value that I want to point out is -16. So let's go ahead and put that over here. And 0 would be over here, right? Negatives are to the right. Now, we have an or equal to, right? So we're going to make this a full circle filled in. And we want values that are less than or equal to -16. So would that be this way or would that be this way? Hopefully you know that that would be this way. These values are less than -16. All right, here's where all the other negatives are, the deeper in the negative. Okay. Now, one way you can show your work and show these graphs is you could do it on like a sketch pad, or I often use the Jamboard, Google Jamboard, and you can write out kind of like how I'm writing here on the computer, right? And then you could take that screenshot and put those in. So that's another way you can show your work, and also allows you to show pictures and graphs is just by doing it on a Jamboard and then taking a screenshot and putting that into your work. Okay. So here, what would be the first thing I do here? Well, I would say distribute this negative. So this negative in front of the parentheses, that's going to get distributed to both of these terms that are in the parentheses. So we'll have 3y minus 2y, then minus 2 is less than 7. Okay. Now, the next thing I would do, I would say is let's go ahead and combine like terms here on the left side. So hopefully you can see, oh, the 3y and this -2y, these can combine, right? So let's go ahead and combine those like terms. And what would be 3y minus 2y? Well, that's just 1y. And then we have a minus 2 is less than 7. Lastly, to get y by itself, we're going to add 2 both sides of the equation. Here we'll have y is less than 9. So on this graph, when we graph it, the point that I want to see is the 9. So let's say 0 is here, 9 will be over here to the left of that. Now, would this be an open circle or a closed circle? Well, it does not have that or equal to. So in this case, it'll be an open circle. And we want values that are less than 9. So the values that are less than 9 are this way. Okay. Hopefully that all makes sense. Okay. Let's go ahead and start task 2, interpreting graphs. Alberto and Bianca. Yeah, Bianca. Alberto and Bianca are running a 50-kilometer race. The image below shows the position of the 2 runners as a function of time. Complete the statement based on the graph. Okay, so again, it's kind of hard to see what's going on here, but you could make it bigger. And it's kind of overlapping other stuff. So, but hopefully you can see that there. You could always hold Control on your keyboard and then press plus, and it'll zoom in. And that works not just for this, but for any web page. Okay. So now that I'm zoomed in a little bit, I again held Control and press plus. And to make it back smaller, you just hold Control and press minus, and you can go back. Okay. But if I'm looking at this and I'm looking at this graph, I could see at the beginning of race, blank runs faster than the other. Okay. So who runs faster at the beginning of the race? So who goes out to an early lead? Well, hopefully you can see that the distance Alberto is covering in the beginning is much more than Bianca, right? So Alberto, we're going to put Alberto here. So Alberto runs faster than Bianca in the beginning, okay? And also to clear this up, you can kind of erase some of this line here by using backspace or delete, and that makes it perhaps look a little nicer. After 1 hour, Alberto has run about blank kilometers. So after 1 hour, so what we would do is look in the x-axis, or in other words, the t-axis, and I want to look at 1 hour. So at 1 hour, Alberto is how far? 20 kilometers. See that? So after 1 hour, Alberto has run about 20 kilometers. And Bianca has run about, so looking at Bianca's, not very far, right? She's like barely up here, like not up to 5 yet. Maybe that's like 1 kilometer or maybe 2 kilometers. Let's just say 1 kilometer. Okay. After running approximately 20 kilometers, Alberto blank for approximately blank hours. So after running 20 kilometers, notice Alberto has this flat line. Now, what is that showing? That's showing that time is still passing, but he's not running any more distance, right? The y-axis is not, he's not going any farther. So after he's run 20 kilometers, Alberto stops running. So Alberto stops running for approximately, so how much time is he just sitting there resting? Well, from 1 hour to 4 hours. So the amount of time he's resting there is 3 hours. So he stops for about 3 hours. Between blank hours and blank hours, blank passes blank. Okay. So notice Bianca's behind, but then all of a sudden Bianca gets ahead in the race, right? So at what point does Bianca become ahead in the race? That's between 3.5 and 4 hours, it looks like, right? You can see on the horizontal axis, that's between 3.5 and 4. So between 3.5 and 4 hours, who passes who? All right. So you should be able to answer that. The first person to cross the finish line. So the finish line is at 50 kilometers. So who gets across the finish line in less time? Well, the blue graph gets up there first, right? So who's that? Should be able to answer that. Part B. The graph shows the attendance at a hockey game by showing the relationship between the number of people in the area and the number of minutes since the arena opened its doors. Describe what each axis represents and then describe what is happening during each of the 9 segments of the graph. Okay, so they open the doors at a hockey game. Notice the attendance goes skyrockets in there, right? So they open the doors and you can see all the people waiting in line essentially. They all get to go in, right? So the amount of people in the arena goes up dramatically right here at 1, right? So here, that's what we would say. So so for each axis, let's first talk about each axis. So the x-axis, represents how many people, or sorry, how much time has passed, right? So the amount of time represents the amount of time since the arena opened its doors. Okay, what about the y-axis? What does the y-axis represent in this graph? Well, the y-axis represents the number of people in the arena. The amount of people in the arena. Now let's talk about what each of these kind of represents. So we have the numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9. So for section 1, and then we'll have to write for each of them. Section 2, section 3, so on. Okay, so go ahead and do that. Write that section 1 all the way down to section 9. So at section 1, they open the doors and a bunch of people come into the arena. Okay, so that's what you would write here. So the arena opens the doors and many people you can kind of see that here, right? As soon as they open the doors, a bunch of people come in. Okay, well, what about that? Now here the slope changes, right, at 2. So what is that showing? That shows more people are still coming in, but at a slower rate. Okay, during section 2, during this section, people are still entering the arena, but at a slower rate. Okay. What about section 3? Well, here, basically no one is coming to the arena, right? The population stays consistent during that period of time. Okay, so nobody is entering or leaving the arena during this time. Or they don't like nor, or, okay, whatever. Okay, and then go ahead and go through just like that. Okay, maybe section 4 is where like, oh, the game's about to start, so a bunch of people come in just before the game. During this section, you know, you just talk about what's going on here, right? Okay. Okay. Task, function notation. So this is the part A of this task. Okay. All right. So part A, the function f of x equals negative 6x plus 11 has the range negative 37, negative 25, negative 13, negative 1. Select the domain values from the list 1, 2, 3, 4, 5, 6, 7, 8. Justify your choices by explaining how you determine the domain values. Okay, so this is, I know it sounds complicated, but it's not that tricky. What you want to do is you're going to check f of each of these numbers. So first, let's check f of 1. So what that means is we're going to, and perhaps I want to write using the equation editor. So in an equation, f of 1, you can see how much more mathy that looks. What that would do for f of 1, you're replacing x with 1. So that would be negative 6 times 1, right? Just like it says negative 6 times x. So here we got negative 6 times, and we're replacing the x with 1, then plus 11. Now what result does that give you? So that would be negative 6 times 1. Well, that's negative 6. Plus 11 is 5. Okay. So what does this answer tell us? Well, is 5 in our list in the range? Well, no, 5 is not in this list. So f of 1 will not be in our domain. Okay, so we could leave that work there, but basically we're going to plug in each of these values. Plug in 2, 3, 4, 5, 6, 7, and 8, and look for these results. So once you found these results, those will be your answers. Okay, so let's keep on going until we find one of our results, for example. Insert. And now we're going to do f of 2 equals, and again, we're using that same function. We're just going to replace the x with 2 and look for what that equals. So negative 6 times 2 is negative 12, plus 11 is negative 1. Okay. Is negative 1 in our list? Well, yes, it is. You see negative 1 right here. So that's in our list in the range. So we would say part of our final answer will be the numbers. Oh, I got caps lock on. The numbers in the domain are, and 2 is the first one we just found. Okay. Now you need to find the other numbers that would be in the domain. So basically find the other numbers that results in numbers in the range. Okay. So there should be 4 of these that produce these 4 results. You just need to figure out which ones. Okay. Hopefully that makes sense. Part B. Jana's parents have given her an interest-free loan of $100 to buy a new pair of running shoes. She plans to pay back the loan with monthly payments of $20 each. Write a function rule for the balance of the function b of p, where p represents the number of payments Jana has made. Okay, so she owes $100, but she's making $20 payments each month, right? So we're basically going to write a function that shows how much she owes after each month. So let's see if we can do that. So we're going to first, let's put whoop, no, we don't want that. Go away. So first, let's put in the equation. So we're going to insert equation, and we're going to do b of p equals, because that's what they want us to show it as, b of p. Now, how do we figure out how much she owes? Well, she owes 100 from the start, right? But as she makes payments, her balance will decrease, right? She'll owe less. So what we want to show is that the amount she owes is reduced by 20 times however many payments she makes. Plus 100. Let's just make sure this works. So here's our function. So if she makes 0 payments, so negative 20 times 0 would be 0, plus 100. Oh, she would owe 100. That makes sense. What if she makes 1 payment? Well, that would be negative 20 times 1. Okay, that's negative 20. Plus 100, that's 80. So if she made 1 payment, she would still owe 80. You see how that makes sense, right? She made one $20 payment, she would still owe $80 to her parents. Okay, so here's our function, our rule. After how many payments will Jana have paid back more than half of the loan? Explain your reasoning. Okay, so since she's making $20 payments, well, we can go ahead and take this same function here. I'm going to just go ahead and copy and paste. Now, after how many payments will she have paid back more than half? So the answer will be after 3 payments, right? So if we do b of 3, this would be negative 20 times 3, which would be negative 20 times 3, that's negative 60, plus 100, this would equal 40. So we can see here that if she makes 3 payments, she'll only owe $40 more, right? So I want you to explain that in a sentence or two. Let's explain that after 3 payments, Jana would only owe $40. So after 3 payments, she has paid more than half of the loan. Okay, question 3. Instead, suppose Jana borrowed $120 to get the newest model of running shoes, and suppose she pays back the loan with monthly payments of only $15. Write a new rule for the balance of the function. Okay, so very similar to what we did here, except here in this question, she's making $15 payments and she owes $120 to start. See if you could write a function that models that. Go ahead and pause the video and see if you can write that function. Okay, so I'll show you what it is just in case you weren't able to figure it out. But it would be this, b of p equals, and she's making $15 payments, so her balance decreases by 15 times the number of payments. And the amount she owes initially is 120. So this would be the function rule that shows her the balance she owes after each payment. Okay. Now for this one, question 4, how long will it take Jana to pay back the loan of the new loan from part 3? So we just came up with this equation. I want you to figure out how many payments it will take for her to completely pay off her loan. So how many payments is she going to need to make in order to pay off that loan? I want you to figure that out and put your work and your answer right here. Okay. Well, with that, you should definitely save it and figure out and put it into the Dropbox and everything else. Okay. Well, I hope that made sense. I hope you're able to get through it. And if you have any questions, if there are any parts that you need more help with, you could always email me. My email is ttrigg@ofy.org. All right. Well, with that, I'll see you guys next time.